Dear students, I am going to teach you the way to find the argument of complex number in the most easiest way. For this, to find the argument or amplitude of complex number of a complex number, you have to know some basic idea. Also, you have to know the rule to find argument. So consider Z equal to IV be a complex number. This is a complex number, a plus IB form. Okay, if you draw in the argon plane, so Z equal to a plus IB will denote a point. Say the point name is P. P's coordinates are a comma B. So if you join P with origin O, then OP will make an angle with the x-axis, and this angle theta is called the argument or amplitude of the complex number. Theta is called the argument or amplitude of the complex number. In the simplest way, we'll find the argument. How to find the argument, you can learn in this video. Argument or amplitude. Okay, for this, learn some basic things that are needed to find argument. Basic things. These basic things are, say, pi equal to 180 degree. In degree measure 180 degree, and in radian measure pi. That is, you know, in my next videos, so how to convert radian to degree or degree to radian. So just know pi equal to 180 degree. Remember, pi equal to 180 degree. Pi by 2 means 180 by 2 equal to 90 degree. Pi by 3, that is 180 by 3, this is 60 degree. Pi by 4 equal to 45 degree. Pi by 6 equal to 30 degree. That is, we shall use pi by 4 instead of 45 degree. We shall use pi instead of 180 degree and 90 degree for pi by 2 and pi by 3 for 60 degree. Okay, then you have to know two formulas here. So tan A plus B equal to tan A plus tan B divided by 1 minus tan A into tan B. Also, tan A minus B is equal to tan A minus tan B by 1 plus tan A into tan B. You will get these formulas in the chapter trigonometry. You can learn in the chapter 7. So just remember this. These are needed in this topic. So again, remember 10 pi by 3 means 60 degree. So tan 60 means root 3. You have to use this. Mainly this is needed. Tan pi by 4 equal to 1, and tan pi by 6, that is tan 30 degree. Tan 30 means 1 by root 3. We will use this. So next, know the rules to find the argument of complex number. Okay, how to find the argument or amplitude of a complex number. Okay, so argument, remember, argument of a complex number denoted by argument of a complex number. Argument of a complex number is denoted by, say complex number z is denoted by arg of z or amp of z, or you may call this theta also, or theta. So now we learn the rules to find argument. Okay, so first rule is, there are two rules to find arguments. So first rule, in the first rule you have to know and remember, this rule is, first rule is, this rule is applicable if z lies on an axis, that is, it may be x-axis, on the x-axis, or maybe on the y-axis. So directly you can find, if z lies on the positive part of x-axis, or you can call x-axis means real axis or real axis, then amplitude of z or theta is equal to 0, that is 0 degree. In degree radian measure 0, and in degree measure 0 degree. We will use here in radian measure. So if z lies on the negative part of real axis or imaginary axis, sorry, not imaginary, or edit, or x-axis, real axis or x-axis, then theta equal to, theta or amplitude of z equal to pi means 180 degree, or you can write 180 degree also. If z lies on the positive part of y-axis. Y-axis is also called imaginary axis. Then theta equal to pi by 2, that is 90 degree. If z lies on the negative part of y-axis, then theta is equal to minus 90 degree, minus pi by 2 or minus 90 degree. Okay, so we'll solve some problems related to the rule 1. Example, find the argument of the following complex numbers. Number 1 says z equal to minus 4i. So minus means negative, only I is there, minus 4i. This z equal to minus 4i lies on the negative part, minus is there, so negative part of y-axis. Okay, so here x is 0, x coordinate is 0. If you convert this in the a plus ib form, then a means 0 plus I into minus 4. So x0 y minus 4, x0 y minus 4, this is y-axis, y minus 4 here. So negative part of, this is negative part, y dash, negative part of y-axis. So z lies on the negative part of y-axis. Therefore amplitude of z or theta equal to negative part of y-axis, then minus pi by 2. So number 2 says z equal to 4i. Z equal to 4i, then this lies in the on the positive part of y-axis. So directly you can write this is pi by 2. Why? Because z lies on the positive part of y-axis. Positive part of y-axis. Number 3 says z equal to 4. Z equal to 4, then this lies on the positive part, positive 4 plus 4. So this lies on the positive part of x-axis or real axis. Z lies on the positive part of x-axis. Therefore theta equal to 0 or 0 degree. Then number 4, z equal to minus 4. Z equal to minus 4, minus is there, so z lies on the negative part of 4 is there, 4 is real, so real axis, that is x-axis. Z lies on the negative part of x-axis, or you can write real axis also. Therefore theta equal to pi or 180 degree. Next, rule 2. Rule 2. This rule is applicable if Z lies on a quadrant. Okay, quadrant. This is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. Y dash, x dash, x is origin of first quadrant. Then this part positive plus plus. Second quadrant, then x negative, y positive. That's right, positive. And the third quadrant negative. And in the fourth quadrant, x is positive, y is negative. So first you have to find the argument or amplitude of a complex number. First you have to know that the complex number z is lying on the quadrant or either a quadrant or either axis. You have to know, this is important. So if z lies on a quadrant, then you have to follow this rule, and if z lies on an axis, then you have to use the first rule. So in this rule, step 1, you have to find alpha. Alpha is any angle from the relation tan alpha equal to modulus b by a. B means this is imaginary part and a means real part. Then you have to go to step 2. In step 2, 4 conditions are there. Step 2, 4 conditions are there. In the first condition, you have to know if z lies on the first quadrant, that is both are positive, x, y positive, a positive, b positive. Then theta or amplitude of z equal to alpha. If z lies on the I wrote 2 times on the negative, second quadrant, then theta equal to pi minus alpha. If z lies on the third quadrant, then theta equal to minus pi plus alpha. If z lies on the fourth quadrant, then theta equal to minus alpha. That is, you can remember like this. This is y-axis, origin, it is x. This is first quadrant, so here theta is equal to alpha. This is second quadrant, this is theta, here theta is equal to phi minus alpha. Here theta is equal to minus phi plus alpha. Here theta equal to minus alpha. And this is positive part of x-axis. So here theta is equal to 0. This negative part of x-axis, theta is phi. And this is negative part of y-axis. This is minus pi by 2. This positive part of x-axis, this is pi by 2 on 90 degree. Okay. So now come to the examples. Example 1. Question is find the argument or amplitude argument of the following complex numbers. Complex number. Number 1. So z equal to 3 plus thrice I. So first decide that whether it is on the quadrant or axis. So this is on the quadrant because both components are there. First component, that is, this is what? Real part. This is imaginary part. So real part is there, imaginary part is there. So both parts are there, then this lies on a quadrant. So any quadrant, but this lies on the first quadrant. This is positive, this is also positive, first quadrant. Okay. So since z lies on the quadrant, so apply rule 2. So in the rule 2, I gave tan alpha b by modulus v by a. So b means 3, a means 3. This is b, this is a. So modulus 1 means 1 only. So 1 means you can write pi by 4. 10 pi by 4. 1 means 10 pi by 4. So if you compare, then alpha equal to pi by 4. So since z lies on the positive, first quadrant, because both are positive, plus. So first quadrant, therefore theta is equal to alpha. First quadrant theta alpha, like this I said. First quadrant theta is equal to alpha. Second quadrant theta equal to pi minus alpha. Third then minus 5 plus alpha. Fourth then minus alpha. So 5 by 4. Finished. So next, number 2. So z is equal to this. First you have to simplify it. After simplification, then that is convert into a plus b form. 2 into 1, 2, twice I, minus I into I square, 2 plus I, this is I square means minus 1, this becomes plus 3 plus I. Therefore tan alpha is equal to b by a 1 by 3. So 1 by 3 only. So 1 by 3. So alpha equal to, this lies on the first quadrant. You can write alpha equal to, so you have not got the value of 1 by 3. That means 1 by 3 means 10 what degree. Okay. So alpha equal to, you can write tan inverse 1 by 3. Since z lies on the first quadrant, z lies on the first quadrant, therefore alpha equal theta equal to alpha equal to tan inverse 1 by 3. So number 3, z equal to 1 plus I whole square. So first break, a plus b square, a square plus b square plus twice ab, 1 square means 1, I square means minus 1, plus twice I, minus minus cancel, so twice I. Twice I means this lies on the x-axis, positive parts of y-axis. This lies on the positive part of y-axis, so I is there, so both components are not there. Since z lies on the positive part of y-axis, therefore theta equal to 5 by 2. Directly rule 1, here rule 1 is applicable because z lies on the on an axis. So number 4, so z equal to minus 4i, so minus 4 plus 4i. So find this lies on a quadrant tan alpha. So if to apply this rule 2, so tan alpha modulus b by a, mod b means 4, a means minus 4 is equal to minus 1, minus 1 means 1, 1 means you can write 10 pi by 4, therefore alpha equal to 5 by 4. Since z lies on the which quadrant, this is negative, then positive, second quadrant. Z lies on the second quadrant, therefore theta equal to pi minus alpha. Pi minus alpha means 5 by 4. LCM 4, 5 minus 5, this will be twice 5 by 4. Number 5, take z equal to say 4 minus 4i. So this lies on a quadrant. So take tan alpha b by a, b means minus 4 by 4 is equal to minus 1, mod 1 then mod minus 1 then 1, positive. 1 means 5 by 4, so alpha is equal to pi by 4. Now observe z lies on the fourth quadrant, positive, negative, x positive, y negative, fourth quadrant. Since z lies on the fourth quadrant, therefore theta equal to minus alpha. Alpha means 5 by 4. Say z equal to minus 4 minus 4i. So this lies on the third quadrant, minus minus, both minus minus quadrant, okay. Both parts are there, both components are there. The real component also there, imaginary component also there. So tan alpha is equal to b by a, modulus b by a. So b means minus 4, a means minus 4, minus 1 minus 4, 1. Modulus 1 means 1 only. This will be 10 pi by 4. 1 means 10 pi by 4. So 10 pi equal to, alpha equal to pi by 4, since z lies on the right quadrant, fourth quadrant. Z lies on the third quadrant. Therefore, theta or amplitude of z equal to minus 5 plus alpha. Minus 5 alpha means pi by 4. Now take LCM. 4 LCM minus 4 pi plus 5, that is minus thrice 5 4.